Good morning. In this Unit 4, we will talk about distributions of random variables and in particular about the mathematical expectation in discrete variables. Okay, so and I will start with this question. What is the probability to earn money by betting 20 euros in the lottery? We know from previous units that the probability is always between 0 and 1. It's a frequency. Okay, so it's important. Probability is always a frequency. But we can ask the following. What is the expectation to earn money by betting 20 euros in the lottery? This is a different concept. Expectation, more or less, is interpreted like the average value, approximately. Okay, then it means that if I play the lottery many times and every time I bet 20 euros, in average, what is the amount of money that I will win or I will lose? Okay, so that is more or less the concept of expectation. Okay, so you know that the average or the mean of a variable is the sum of all possible values divided by n. Okay, this is like quite a basic concept. But what happens if the number of values is infinite? Okay, so it happens when we don't know exactly values, but we know the distribution about the values. So we know we need a more general concept about the average or about the mean. Okay, for example, imagine that we have a die, we throw the die infinite number of times. We don't know exactly the values, but we know that the values from 1 to 6 on average, they will appear with the same frequency. In that case, what is going to be the average value of the points obtained? Okay, well, so we can think a bit about this situation. So we can have the values. Then imagine that we sort the values. So from 1 to 6, from 1 to 6, infinite number of times. So the average of this column is exactly equivalent to the average of the values from 1 to 6. So we can make the average, and this is 3.5, which is something curious because the points that we obtain from the die is a discrete variable, but the average is a continuous variable. It can have decimals, there is no problem. Okay, so we have the following formula. The average for a discrete variable is the sum of every possible value multiplied by the probability function, which is the probability that this variable takes every particular value. In this case, that would be the value 1, its probability is 1 over 6, plus the value 2 multiplied by 1 over 6 plus 6. Okay, you can see that this formula is exactly equivalent to this intuitive formula that we derived previously. Okay, so this is the formula that we are going to apply. Always that we have a discrete variable and we want to compute the average, we will apply this formula. Okay, so this is the calculation of the mean or of the average for discrete distributions. And this is the mathematical expectation. Okay, I will define a bit better this concept, but more or less the expectation is like the average. Okay, then the mathematical expectation is very important in gambling. Of course, if a company has a business of gambling, it's very important what is going to be the profit of this business, and then this kind of mathematical calculations are very important. And this is an exercise. Imagine that we throw a die, and imagine that if the result is odd, which means that if I get a value 1, 3 or 5, the player has to pay so many euros as point obtained. It means that if it is 1, the player has to pay 1 euro. If it is a 3, he pays 3 euros, and so on. Okay. Sorry. Then, but if the result is even, if it is 2, 4, or 6, the player earns so many euros as points. Okay, so if the value is 2, he receives 2 euros. If it is 4, he receives 4 euros. So what is the average amount won per play? Well, so we have to define first the variable money earned by, per play. The possible values are 2, 4, 6, or -1, -3, and -5. And then we have to think about the probability of every one. In this case, as it is a die, every possible value is the same, and then we multiply. So we apply the formula for the average of a discrete variable. Every possible value multiplied by the probability. These are the possible values. The probability is 1/6. So on average, we are losing 1/2 of a euro. So on average, 50 cents are lost per play. Okay, so properties of the mean. Properties for any kind of distribution. If I have two random variables, x and y, and we sum them, okay, so the average of the sum is the sum of the averages, which I think makes a lot of sense. Okay. Another property, what happens if I have a random variables, I have a column of values and all of them are multiplied by 3? Okay, well, so the average of this new column of variables is 3 times the average of x. So for all types of distributions, okay, these formulas apply for any kind of distribution. In general, we can say that the mean of a linear combination of variables is the linear combination of the means. So now let's think about this exercise. This is an application of these formulas. Imagine that we throw at the same time 2 dice and we sum the points. What is going to be the average? Okay, so we throw the dice and this is the result from the first die, this is the result from the second die, and then we sum. So the minimum of the sum is 2, the maximum of the sum is 12. This is the probability function. This exercise appeared in a previous video. Okay, so we can count the frequency of the different values and then this is the result. Okay, so now we apply the formula for the mathematical expectation for the average of the mean, which is this formula. So the minimum value is 2, so 2 is multiplied by 1 divided by 36, plus 3 multiplied by 2 over 36, plus 4, and so on, until the last value, which is 12 divided by 36. Okay, so we make this operation and we obtain the value 7. Great. Okay, this is more or less somewhat complicated because we have to think about the possible values of the sum and so on, but there is a much easier way to do that. Actually, we're summing 2 variables. We're summing the values from the first die plus the value from the second die. Okay, so we apply this formula that I was explaining in this slide. So we can say that the average of a sum is the sum of the averages. So 3.5 plus 3.5 is 7. So you can see how we get exactly the same solution. Okay. Then another exercise could be the following. Imagine that we have values of height and the average is 1.6 meters. What is going to be the average if we have those measured in centimeters? So obviously that would be multiplied by 100. So in discrete variables, okay, this is now the real exact mathematical definition of expectation. In discrete variables, expectation is defined as following. We have a random variable, x. Now we have a function of x, and then the mathematical expectation is defined like following. Okay, the expectation of a function is the sum of this function multiplied by the probability function. Okay, now what is the expectation of x? Okay, so if this function is x, which is the most simple formula, the most simple function possible, okay, the expectation of x is the average. Okay, so if we particularize, if we make this function x, it becomes the previous formula that I explained in the previous slide. So that is the average. Okay, so we usually express like that. The expectation of x is the same as the average. So many times in statistics we put this, but it is exactly as talking about the average. So the average is the average, or the mean is the expectation of x. So it is this formula that I explained in the previous slide. Okay, for all values of the sample space. Okay, but what happens if this formula, if this function h of x is x minus m squared? Okay, well, in that case, the expectation of x minus m squared is the variance. And this is important. Okay, so now we take the general formula, we take this function h of x, and then we put every value minus the average squared, and that is the variance. Okay, that is the variance. for any kind of discrete distribution. If I make this square root, remember that always the square root of the variance is called the standard deviation. Okay, then we can apply properties of the variance. So by definition, the variance is the expectation of x minus m squared. But then we can make this binomial, okay? So multiply this binomial, and then you know that in mathematics it is the square root of the first plus the square root of the second minus 2 times the first multiplied by the second, okay? In this case, so we have the expectation of something, okay? Then applying the formulas that I explained before, the expectation of a linear combination of variables is the linear combination of the expectation. So we have the expectation of x squared, okay, plus m is a constant, okay, so the average of a constant is that constant itself. So we put here plus m squared, and then it is minus 2 times m, a constant, multiplied by the expectation of x. But the average of x is also m, so we have minus 2m squared, okay. So at the end we have the expectation of x squared minus m squared. So this is another way, an equivalent way to compute the variance. Sometimes this way is easier, so we can apply any of them, okay? So this is exactly an equivalent way to compute the variance. So, and now let's apply these formulas as an example. Imagine that we have a die, we throw the die infinite number of times. What is the variance of the points obtained? Okay, so we can apply this, which is the general formula. So every value of x minus m squared, okay, so 1 minus 3.5 squared plus 2 minus 3.5 squared until 6 minus 3.5 squared divided by 6. So this is 2.92. But there is this second equivalent method, which is that we make the expectation of x squared, which means 1 squared plus 2 squared until 6 squared divided by 6 minus 3.5 squared. So you can see how this calculation is like more simple. The result obviously is the same. Okay, but now also based on the expectation we can compute the skewness coefficient. In the case that we have infinite number of times, like this example of throwing a die infinite number of times. What is the skewness coefficient? Okay, so the coefficient of asymmetry is this, is the expectation of x minus the average power to 3, then divided by the standard deviation power to 3. Okay, so also based on the expectation we can compute the kurtosis coefficient, which is this. So instead of 3, here in the formula we have a 4. So we end up that the concept of expectation is something quite general, that allows us not only to compute the average, but also the variance, also the skewness coefficient, and also the kurtosis coefficient. So expectation is like a broad concept in statistics that is applied always that we don't have a discrete set of n values, but we have infinite numbers of a given distribution. Okay, so this is more or less the conclusion of this video. Expectation allows us the calculation of mean, variance, coefficient of kurtosis, skewness of any kind of distribution. And here I finished this video about mathematical expectation in discrete variables. Thank you very much for your attention.